Okay, in this video, given h of x equals negative 2 times x plus 4 over 5 and g of x equals negative 10 times x plus 4 over 4, are h of x and g of x inverse functions? So one of the first things I am going to do is I am going to clean this up so it's a little bit easier to read these functions because I don't like the notation that they're used here. So for h of x, I can rewrite that as simply negative 2/5 of x plus 4. That's a lot easier to read for me. And for g of x, I'm going to rewrite it as negative 10/4 of x plus 4. Now, if I need to, I can go ahead and clean up my fractions. I'm going to go ahead and leave it as they are for right now to show you what we're actually testing here is, are these two functions inverses of each other? Does one of these functions undo the other is really what we're asking. Okay, so the assumption is that they are. So we are assuming, or this is our assumption, is that h of x is an inverse of g of x. And vice versa. We can say that g of x is an inverse of h of x. So if I take one of these functions like g of x and I plug it into h of x, I should get back x as the output if they are inverses. So all I need to do is test one of them. So I'm going to test the g of x is an inverse of h of x. So we're going to take h and we're going to pass in g of x. And I use the brackets because it's a little bit cleaner to read when you're having all these parentheses. So h of g of x is equal to, now h of x was negative 2/5. Then we had our parentheses. I'm going to use the brackets in this case. And then we get to the x. Let me pull that down here. We get to the x and we replace it with g of x. And then we still had plus 4 right after that. Okay. Now what I do is for every g of x, I replace it with negative 10/4 of x plus 4. So negative 2/5 of negative 10/4 of x plus 4 plus 4 again. So this g of x replaced with all of this piece, and then I still had to bring the other plus 4 down. Okay, next step is I'm going to go ahead and distribute here. So this is going to give me negative 2/5 of negative 10/4 x. The 4s are going to cancel each other out, so this becomes minus 10 plus 4. I am then going to distribute. I'm also going to go ahead and combine so that this becomes minus 6. So then this makes the distributive property to the negative 6 rather than to both of these terms. So this now gives me negative, well, let's go through this part here. We have negative 2/5 times negative 10/4. That's going to give us a positive. The 2 and the 4 are going to give me 1 and 2 respectively. The 5 and the 10, so this is going to become positive. The 5 and the 10 is going to become 1 and 2 respectively as well. The 2's become 1, the 1's become 1, so this is just going to leave us with a single x here. And then we still had minus 6. So here we're going to take, so minus, or actually it's a negative times a negative, so it's to be plus. And now I'm going to go ahead and show this part here. So plus 2/5 of 6. Now this is just going to give us x plus 12/5. And so the assumption again was that they are inverse functions. Well, if they were inverse functions, we should not have that plus 2/5 part of it. Okay, so h of g of x returns x plus 12/5. So this tells us that g of x is not inverse of h of x. Okay, again, remember our assumption is that h of x or g of x is an inverse. So we were expecting to get f of x, or I'm sorry, h of g of x to return x. And I actually got, instead of just x, I got 12/5 more of x. Okay? So they cannot be inverse functions of each other.